Hi and welcome. In this video, we are going to be solving logarithmic equations. So let's jump right in. First, let's talk about what is a logarithmic equation. So any equations that contain variables inside a logarithmic expression is called a logarithmic equation. So as we can see here, our variable x is inside the logarithmic equation. We're trying to say log base 2 of what value will equal 4. Or here, if we have a couple logarithms that have a variable in the expression, these are logarithmic equations. And so the way that we're going to solve this is we are going to try to obtain a single logarithmic expression on one side using properties of logarithms. I do have another video that talks about the properties of logarithms if you want to look at that. But basically, we are going to take any multiple logarithms like we see here, combine them using either the quotient rule, the product rule, or the power rule, and then write it in exponential form. So when we talk about writing it in exponential form, that means recognizing that every logarithm can be written as an exponential equation. So what this logarithm represents is this base of the logarithm raised to this power equals this expression. So I can rewrite this as a to the y equals x. And notice that by doing that, it'll allow us to solve for that x. That's what we're trying to solve for. So if we have a single logarithm and we rewrite it in this exponential form, we can solve for that variable. So let's get started with that. So for my first example, I want to solve log base 3 of x equals -2. So we already have it here as a single logarithm. There's no need to combine it in any way. So I can go ahead and write it in exponential form. That means that this base 3 raised to this power equals x. So if I rewrite that, 3 to the -2 equals x. Well, 3 to the -2 power is the same as the reciprocal of 1 over 3 squared, and 3 squared is 9. So our solution here for x is just 1 over 9. That's it. And you can check your answer by typing that into your calculator. So if I was going to check this, I would do log base 3 of 1 over 9, and we want to make sure, does that equal -2? And I actually have a calculator here available that we can look at for that. So there's a couple ways that I can type this in. If I'm doing the change of base formula, I can type this in as log of 1 over 9 over log of 3. So let me try that. If I do log of 1 over 9 divided by log of 3. Notice I'm closing each of those parentheses there. That does equal -2. So therefore, we have confirmed that this is our solution. All right, let's try the next example. So here we do have two separate logarithms that we need to combine into a single logarithm before we can change it to exponential form. And so since I have the sum of two logarithms that have the same base, these are both the common logarithm of base 10. Since I have the sum of two logarithms, I can combine that into a product using the product rule. So since I have log plus log, I can combine it into the logarithm of those two values multiplied together. And now that I have it as a single logarithm, I can change it to exponential form. Now, again, as I just mentioned, you need to know what the base is of this logarithm. If this is the common logarithm, that means it's implied that the base is 10. So when we are writing this in exponential form, we're doing base 10 to this power equals this expression. So I'm saying 10 to the first power equals x times x plus 3. And now I can go ahead and solve this for x. 10 to the first power is 10. On the right-hand side, I'll distribute x squared plus 3x. And so now when I'm trying to decide how to solve this equation, we've noticed that we have an x squared and an x. This is going to be quadratic in form. So the best way to try to solve this is to maybe set it equal to 0 and see if I can factor it. So I'm going to subtract 10 from both sides so that now I have x squared plus 3x minus 10 equals 0. And if we can split it up into two factors, then that will be a great way to find our solutions. So I'm looking for two values that multiply to negative 10 that add or subtract to give me 3. So products of 10 could be 5 and 2. And in order to get that positive 3 in the middle, it'd be positive 5, negative 2. When I multiply those values, it'll give me negative 10 at the end. When I add those values, it gives me a 3 in the middle. Perfect. And I can set each of those factors equal to 0 and solve for x. So here, when I have x plus 5 equals 0, we get x equals negative 5. When I have x minus 2 equals 0, we get x equals 2. Now, it's very important that we check our solutions here because we're going to notice something interesting happen. If I have log of negative 5, let's check that one first. If I do log of negative 5 plus log of negative 5 plus 3. Let me go ahead and bring down my calculator again. And I'll have to erase this work over here on this side so we can see it. So I'm going to do log of negative 5 by itself in my calculator and just show what happens there. So if I type in log negative 5, we're going to see that that gives us an error because we can't take the logarithm of a negative number. It doesn't exist. So what that means is x equals negative 5 is not a valid solution. It does not exist in the context of the original problem. So that's not going to be one of our possible solutions. So let me try plugging in positive 2 instead. So if I plug in positive 2 here for x, we get log of 2 plus log of 2 plus 3. Well, that's log 2 plus log 5. And we need that to equal 1. So let me come back to my calculator and clear this. And so I'm doing log 2 plus log 5. And we see that it does equal 1. So that means that our only solution, even though algebraically it looked like we had two solutions, our only valid solution is x equals positive 2. Okay, let's look at our next example. Here we have the natural log of 4x plus 6 minus the natural log of x plus 5 equals the natural log of x. Again, our goal is if we have these multiple logarithms on one side, we want to combine them. And we can combine the difference of two logarithms by using the quotient rule. So that means if I'm subtracting two logarithms, I can rewrite it as the log of that first term over the second. 4x plus 6 over x plus 5. And that equals natural log of x. Now, it's something interesting here. We actually don't want to change this to exponential form. We can actually cancel the logarithm that's on both sides. This is another property of exponents. It's the property of logarithmic equality, that if we have two expressions that have log of the same base on each side, basically those can cancel out and we can just solve the equation that's left over. We can just solve 4x plus 6 over x plus 5 equals x. And that's only because they had the same logarithm on both sides of the equations. In previous examples on other videos, we've been able to apply the logarithm to both sides in order to solve exponential equations. Now, same idea, we can remove it from both sides and just solve for x. So now algebraically, so let's see, since we have a quotient here, since we're dividing by x plus 5, let me go ahead and multiply that on both sides. So we can kind of just get rid of that fraction. So now I have 4x plus 6 equals, I'll distribute here, x squared plus 5x. kind of just like my last example where we had this x squared term, this quadratic, we should set this equal to 0 and see if we can solve it. So I'll subtract 4x from each side. I'll also subtract 6 so that this entire left-hand side is equal to 0. When I combine terms on the right, the 5x minus 4x is 1x and then minus 6. So let me rewrite this over here to give myself some room. I have x squared plus x minus 6 equals 0. And so if we try to factor this, we're looking for two numbers that will multiply to -6 that add to 1. I'll try 3 times 2. If I do a plus 3 and a minus 2, that product is -6. The sum gives me that 1 in the middle, so that's perfect. I can set each factor equal to 0. We get x equals -3 and x equals 2. Now, as we saw with the previous example, we don't want to automatically eliminate this x equals -3. You need to look at it in the context of your original problem. So if I plug in -3, will it cause any of these to be negative? If it does, then we have the problem. And actually, it will cause a problem here on the right-hand side. So if I plug in -3, into this first one, we get, let's see, that'll be -12 plus 6, which will be -6. And then on the other, minus natural log of, if I plug in -3 here, that gives me 2. But again, as soon as we have the logarithm of a negative number, which I would have had on either side, then automatically that means that that's not going to be a valid solution. So we can say, okay, this x equals -3 is not going to be a possible answer. So let's check that +2. I'll check it over here. If I plug in +2, that's 4 times 2, which is 8, plus 6, minus the natural log of 2 plus 5, equals the natural log of 2. So this is the natural log of 14 minus the natural log of 7. We want that to equal the natural log of 2. I can actually simplify this if I want to using the quotient rules. That'll be the natural log of 14 over 7, which we know will simplify to natural log of 2. So once we get to this point, we can say yes, that is our valid solution. So our solution for this equation after combining the logarithms and solving for x is just x equals 2. And I think I have one more example. So here we have log base 8 of x plus 1 minus log base 8 of x equals 2. Again, we see that we have that quotient of two logarithms that we're going to write. So I have log of 8 of x plus 1 over x equals 2. So since we were subtracting two logarithms with the same base, I can combine it as a single quotient. And if you want to write parentheses around all that, you can. Once I have that single logarithm, now I can change it to exponential form. I don't have a logarithm on the other side, so instead we're saying 8 to this power equals this expression, or 8 to the second power equals x plus 1 over x. 8 to the second power, that's 8 times 8, which is 64. And now I have this algebraic equation that we can solve for x. Since I'm dividing by x, let's go ahead and multiply that on both sides. And so that gives me 64x equals x plus 1. We have x on both sides of the equation, so let me combine those. I'll subtract an x over here to the left. 64x minus another x is 63x. And on the other side, we have equals 1. And so to solve for x, since x is being multiplied by 63, I'll divide 63 on both sides, and we get x equals 1 over 63. And again, we're going to keep it in that form. We're not going to write it as a decimal. And we're going to check our answer. So I want to check, does log base 8 of 1 over 63 plus 1 minus log base 8 of 1 over 63, does that equal 2? So in my calculator, I want to show you a way that we can type this in. So I am going to, let's see, I'm going to erase some of this now. Hopefully you got all that. And I'm going to show us how we can, another way that we can type these logarithms. So last time I typed logarithms in my first example, first or second example, I used the change of base formula. Another way, if you have this Texas Instruments TI-83 or TI-84, there is a log button here. And so if I go to the math menu, and then I believe it's at the very bottom. So I'm actually going to scroll up. And that gets me to this log base. And if I press enter, it allows me to type in whatever base it is that I need to type in. So I'm going to do log base 8. In the parentheses, I have 1 over 63 plus 1. And then I'm subtracting. And to get that log base 8 again, I go to math. And then notice I'm pressing the up button a couple times to get to that log base. Enter. Log base 8 of 1 over 63. And now when I press enter, hopefully we see it equals 2, which it does, which means that our solution of x equals 1 over 63 was our valid solution. And that's everything that I have for today. So if you have any questions, remember that you can leave a comment and let me know. Hopefully you learned something today and that you found this very helpful. I appreciate you being here. And remember, I have more videos available for you to watch on my page. Keep checking because I plan to continue making videos for you. Thanks so much. Take care.